Mosquitoes are seeing red. These new findings about their vision could help you hide from these disease vectors. This is by University of Washington on phys.org. Beating the bite of mosquitoes this spring and summer could hinge on your attire and your skin. New research led by scientists at the University of Washington indicates that a common mosquito species, after detecting a telltale gas that we exhale, flies towards specific colors, including red, orange, black, and cyan. The mosquitoes ignore other colors such as green, purple, blue, and white. So this is what we should wear in the evenings, even though mosquitoes bite us all day long. Now, these researchers believe these findings help explain how mosquito finds hosts, since human skin, regardless of overall pigmentation, emits a strong red-orange signal to their eyes. So the colors that they like are red, orange, black, and cyan. The colors they ignore are green, purple, blue, and white. Now, mosquitoes appear to use odors to help them distinguish what is nearby, like a host to bite, said senior author Kiley Riffell at UW Professor of Biology. When they smell specific compounds like CO2 from our breath, that scent stimulates the eyes to scan for specific colors and other visual patterns which are associated with a potential host and head to them. The results published just yesterday, February 4th, in Nature Communications, reveal how the mosquito's sense of smell, known as olfaction, influences how the mosquito responds to visual cues. Knowing which colors attract hungry mosquitoes and which ones do not can help them design better repellents, traps, and other methods to keep mosquitoes at bay. One of the most common questions I'm asked is, what can I do to stop mosquitoes from biting me, said Riffell. He says, I used to say there are 3 major cues that attract mosquitoes: your breath, your sweat, and the temperature of your skin. In this study, we found a 4th cue, the color red, which can not only be found on your clothes, but also found on everyone's skin. I support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. They explain that the shade of your skin doesn't really matter. We're all giving off a strong red signature. Filtering out those attractive colors in our skin or wearing clothes that avoid those colors would be another way to prevent a mosquito biting us. In their experiments, the team tracked behavior of female yellow fever mosquitoes, the Aedes aegypti, when presented with different types of visual and scent cues. Like all mosquito species, only females drink blood, and bites from A. aegypti can transmit dengue fever, yellow fever, chikungunya, and Zika. The researchers tracked individual mosquitoes in miniature test chambers into which they sprayed specific odors and presented different types of visual patterns, such as a colored dot or a tasty human hand. Without any odor stimulus, mosquitoes largely ignore a dot at the bottom of the chamber, regardless of color. After a spritz of CO2 in the chamber, mosquitoes continued to ignore the dot if it was green, blue, or purple in color. And also white, we can wear those. But if the dot was red, orange, black, or cyan, mosquitoes would fly towards it. Humans cannot smell CO2, which is the gas we and other animals exhale each time we breathe out. Mosquitoes can. Past research by Riffell's team and other groups showed that smelling CO2 boosts female mosquitoes' activity level, searching the space around them, presumably for a host. The color dot experiments revealed that after smelling CO2, these mosquitoes' eyes prefer certain wavelengths in the visual spectrum. It's similar to what might happen when humans smell something good. Riffell said, imagine you're on a sidewalk and you smell pie crust and cinnamon. That's probably a sign that there's a bakery nearby, and you might start looking around for it. Here we started to learn that what visual elements that mosquitoes are looking for after smelling their own version of the bakery. Most humans have true color vision. We see different wavelengths of light as distinct colors. 650 nanometers show up as red, while 450 nanometer wavelengths look blue, for example. The researchers do not know whether mosquitoes perceive colors the same way that our eyes do, but most of the colors the mosquitoes prefer after smelling CO2, orange, red, and black, correspond to longer wavelengths of light. Human skin, regardless of pigmentation, also gives off a long wavelength signal in the red-orange range. When Riffell's team repeated the chamber experiments with human skin tone pigmentation cards or a researcher's bare hand, mosquitoes again flew towards the visual stimulus only after CO2 was sprayed into the chamber. If the researchers used filters to remove long wavelength signals or have the researchers wear a green-colored glove, the CO2-primed mosquitoes no longer flew towards the stimulus. Genes determine the preference of these females for red-orange colors. Mosquitoes with a mutant copy of a gene needed to smell CO2 no longer showed a color preference in the test chamber. Another strain of mutant mosquitoes, with a change related to the vision so that they could no longer see long wavelengths of light, were more colorblind in the presence of CO2. These experiments lay out the first steps mosquitoes use to find hosts, said Riffell. More research is needed to determine how other visual and odor cues, such as skin secretions, help mosquitoes target potential hosts at close range. Other mosquito species may also have different color preferences based on their preferred host species, but these new findings add a new layer to mosquito control, which is color. Co-lead authors on the paper are Diego Alonso San Alberto, researcher lecturer at UW Department of Biology, and Claire Rush, UW doctoral alum in biology. Co-authors are Yin-Pen Zhang and Craig Montel, University of California, Santa Barbara, and Andrew Straw, University of Freiburg in Germany. The research was funded by the National Institutes of Health, the Air Force Office of Scientific Research, the UW, and the U.S. Army Research Office. This is on phys.org by University of Washington. Please leave your comments, and thank you for your support. Just to recap the colors, the mosquitoes ignore colors such as green, purple, blue, and white, so we can wear those in the evening. Green, purple, blue, and white. And they like red, orange, black, and cyan.